Okay, hello. Here we are again in Saburly Talk, code quality. We're talking about code quality and not about process now. And we are talking about other ways of controlling the flow, the alternative ways, the unusual ways. So, as you always see at the beginning of this slide, these are our core values. So, um, we'll be talking about controlling the flow with multiple returns from one method function, using recursion as a flow, as a way of directing the flow of the program, and using go to statement. When it comes to multiple returns, they are encouraged to be used when it helps readability. Otherwise, they should be avoided. There are some cases where they are really great. So, for example, when you have guard clauses, if you have a lot of conditions that need to be fulfilled in order to work in for the work in the routine or function to be done correctly, then instead of like nesting a lot of ifs and then doing the code after all the conditions are met, it is best to like return early with the error message and something like that at the beginning of the method, and then at the rest of the method, then you have a clear way to do the job. So it's much more readable that they will see after that. Also, it is like sometimes you can use multiple returns when there's nothing to do after you find a result or something like that. That's not a bad situation. So you could use that in order to not to duplicate like code that needs to be done for the cleanup. This is an example where we can use multiple returns as soon as we get the result, because there's nothing else to be done after you find out, for example, the result of the comparison. So you could return a result right away. And this is a code when multiple returns are preferable to one return. For example, if you have I was talking about that. If you have a lot of conditions, 3 conditions here for code to be done correctly, you can like put them at the beginning and then write the code after, and that's much more readable than the first one. So yeah, that's it about multiple returns. There's not much to talk about. There's a big debate about it. Sometimes the people who debate style, some are for it, some are after it. I think I like these cases. These 2 cases are common use of multiple returns when it's like actually beneficial. In other cases, as always, you have to take into consideration what you are getting there and what you are losing by using multiple returns. It can be sometimes confusing. It can lead to code duplication sometimes, but yeah, that's it. So we'll go on to recursion. Recursion is it's hard to understand for a lot of developers. Actually, the recursion and pointers are 2 things that, according to some researchers, that computer science students go out from universities without knowing. So you should prefer iteration unless recursion is better. Basically, a lot of things in the modern programming languages, almost all things can be done both recursively and iteratively. So you have to check both cases and then quickly, and then figure out which one is more readable. That's the case. For some problems that can be divided into similar looking smaller problems, the recursion is a given. Like, it really simplifies the code. Some problems are like traversing the tree, or for example, finding a maze, finding an exit from a maze. There are some problems, or going through the graph or something like that. Some problems are really, really good for recursion, and if you were to do it iteratively, and you can, it would be much uglier solution, much less readable. And of course, as I said, it is hard to understand for a lot of programmers. So unless you get a lot of benefit from it, like, don't use it. The exception are functional programming languages, purely functional programming languages that don't allow you to modify a variable. So in those cases, I mean, there's no other way to iterate through the list or do a lot of common things without recursion. So if you are using Haskell or I don't know what other programming languages we could be using, basically you should go wild with the recursion in these cases. Let me pass. So when you are using a recursion, make sure that it has at least one non-recursive call that's actually called. So in order to avoid infinite recursion. So that's a common mistake, where you then get you run out of the space on the stack, and then your program terminates, or you get an exception or stuff like that. There's for complex problems that you are not sure that can have a lot of calls on the stack, and if it's not a tail recursion, you could use safety counters. It's basically a variable that you pass down. It cannot be. It has to be passed down through parameters, or be inside a class on the upper level, so that it retains its value through the recursive, like, chain of recursive calls, and you determine a sufficiently large limit to the execution. Then if that limit is reached, then you terminate, because in some problems it's hard to predict how much it's hard to predict how many. Just a second. Amir, could you like mute your could you mute your Okay. Amir, could you mute your microphone, because we are getting information from your boss that we shouldn't be getting. Okay, I'll do it. Okay, so where was I? Yeah. Well, as I said, safety counters are good for when the number of calls in the chain can be a lot larger than the limit, and then you could use safety counter to see if to prevent an exception. So yeah, also when you are doing recursion, limit it to one routine. So if A calls B, which calls A, that's really hard to. I mean, even like single routine recursion, it's sometimes hard to reason about. But having multiple methods call each other, then if you didn't make a mistake in it, like, the other developers can easily change something, and then the whole thing breaks down. The more the more methods are involved in the recursive, the worse situation gets. So now we'll talk about some. Here are some examples of here's a factorial in maths when we are like calculating factorial, like the definition is almost always recursive, but it's not a good way to calculate it recursively in practice, because the iterative version is much more readable, and even like more performant depending on the programming language you use. So like in some cases, although it is like it is a common way of presenting in math, in mathematics, it's not always the best idea to do it in programming. So yeah, we'll talk about go-to. Go-to is a statement that was like that's now mostly used in low-level languages, but sometimes it was in some languages it was maybe the only way to control flow. It's basically used for jumping around code. You can use it to jump around code wherever you want. In the early days, the line numbers were used, but you could use but in the modern like C or C++, you can use labels and jump to labels. Very famous computer scientist Dijkstra, you know him. At least you had heard about his algorithm for like finding the shortest path. He wrote an essay or a white paper, or I don't know what is that was called like Goto Considered Harmful in 1968, and he figured out that most that programs that he looked at that used Goto had a lot more bugs than the programs they didn't use Goto, that used the other ways of controlling the flow. This is like a typo, Knut, not Kunt. He also found some ways in which Goto can even make the program larger and more complex. And the main argument for using Goto is like that it makes code simpler. So basically, when these two guys say something in computer science, a lot of people listen, because these are really the experts. So most of the modern languages do not include Goto statement at all. So we are like, we don't have a choice to use it. Jumping around with Goto can be bad for optimization and bad for readability. Okay, this is like additional. Okay, so it's sometimes really good to use Goto, but those are the cases that are not often. And since we mostly use languages that do not have Goto, we don't have to worry about them. So it's safe to say never use Goto, even in C++, because even if you have a really good reason, you'll have to defend it against like other developers, because it's almost a common it's almost a common wisdom. No one will allow you in the code reviews to use Goto, so don't use Goto. Okay, any questions? No questions. Okay, so that's it. See you around sometimes, maybe next Tuesday and maybe not.